Hello, I'm here to go over the final part of the Xfoil project, which is this one right here, part 3. And in part 3, we're looking mostly, well, again, just only at the Clark W airfoil, except here we're looking at the addition of flaps to go along with this airfoil and just see how it affects the performance or the drag coefficient or whatever you want to look at. So to start out with, we're doing it at Reynolds number of 1 million, and I've already gathered this first Clark W airfoil with no flap um, in the very first part, so I won't go over that. I'm just going to start with the flap at 10 degrees because that's kind of the new information that the part's asking for. So I'll just load up the Clark W file. Let's see, make sure everything's looking right. Change this real quick. Okay, so we have that changed. And then next, we're going to go to the design, pull it up here. I set my hinges for my flaps. Well, we just type in flap to get to the flap. But for the X hinge location, I set it at 0.7. It didn't specify in the assignment, but that's where he did it in the tutorial. So I went along with that. And the same along with it being at 0.5 relative to the y over t. And then the first deflection is 10 degrees down. So I'll just type in 10. And as you can see, we have it right here. And finally, I'm just going to type exec so it comes through. Type in PPAR to make sure it's looking right. And as you can see, it has a downwards angle now. Okay, and then after this, I'm going to do just kind of the same things we've been doing. Viscous, Reynolds number of 1 million. And then, let's see, get 100 iterations. Basic 515.1. It's the same deal. We're just going from alpha -5 to alpha 15, increments of 1. There we go. As you can see, we have our graph here. It's looking pretty neat, I guess. I've already kind of explained how I saved the files and uploaded them in Excel in the previous videos, so I'm going to just skip that part just so I can get through to the next flap real quick and then show the Excel and show all the data I found. So I'll exit out of Xfoil, open it back up. I mean, we're doing the exact same thing, more or less. Clark W file, open it up. Let's get my nodes looking right. 50 G1. We'll go to the designer. Put on node flap 0.7. Half thickness. And this time we're going 20 degrees down. So I mean, it's the exact same thing. I just changed 10 to 20. You can see it right here. Execute it. Make sure it's looking right. Yep, we have our 20-degree downward angle. And then, I mean, it's the exact same thing. Change it to viscous, 1 million. We get our sequence from -5 to 15. And let's see, as we can see, we have it here. Well, some of the convergence has failed, and that's why I did have to play around a bit with the node count, because I would get some of the angles, but not the other ones. Here, I guess I'll save a file to show it. I'll just put it in as example. I don't want to save over anything. I'll initialize it. And the same thing, but this time we will look at the thing itself. And as you can see, it skipped completely through -5, -4, -3, and then also it skipped 3 and 14 and 15. So to remedy that, when I was doing the Xfoil, I would change the node count for some, because for whatever reason at this node count it wouldn't converge some of the time. So if I change it to 120, T still 1, go back to operations. Oh, there we go, operations now. Let's see. And I would go from 0 to like -5, just that part specifically, because I read online that starting from 0 would help your convergence sometimes, because a lot of times Xfoil just doesn't want to converge. And we'll see if this helped any. Let me reopen this file. And as we can see here, it didn't work completely too well, but this time it did give us our -3 alpha. And I just kind of went through changing the nodes until I could fill out, most of the information. This is looking different kind of than whenever I did it. I found that with Xfoil, I'll run something once and it looks one way, and then I'll run it again and it won't converge at different points. So this run is a little different than whenever I was working on it earlier, but that's kind of the gist of how I went through piece by piece and got each alpha location. Don't save that. Go ahead and delete that. But then after that, I did the same thing where, you just open the text files to Excel. I already have my files that I got all in my one Excel here, but as you can see, I've just grouped it up, no flap, 10-degree flap, 20-degree flap. I just created these graphs in Excel, just the way you're supposed to, just inserting a graph and then putting all of my data points together. And then finally, with my Word document, I have the graphs here again, and then here now I have my table, find the max lift coefficient, where it's at, minimum drag, where it's at, max aerodynamic performance, and where that's at. So that was about it for how I approached this project. This is the final part for it, and should be the final video. Thank you.